Very good morning, my dear students. Today I am going to start chapter 4, that is Analytical Chemistry. This chapter is about the analysis of salt. Analysis means to find out the composition of the salt. There are two types of analysis, qualitative and quantitative. Now, qualitative analysis deals with the detection of metallic cations, which are also known as basic radicals in the unknown salt sample, or detection of non-metallic anions, which are known as acidic radicals. And quantitative analysis is related to find out the percentage of the element present in a particular salt sample. So in your syllabus it is only qualitative analysis, so we will focus in this. And in qualitative analysis also it is only about the detection of metallic cations in the unknown salt sample. Today, the metallic cations which I am going to discuss, that is your copper Cu2 positive, ferrous Fe2 positive, ferric Fe3 positive, lead Pb2 positive and zinc Zn2 positive. How we can find out this metallic cation in unknown salt sample? So first of all, for finding the metallic cation in the salt sample, we have to use certain reagent. The reagent which we use here, that is sodium hydroxide solution. We can also use KOH, that is caustic potash, or potassium hydroxide, or ammonium hydroxide. But with the help of ammonium hydroxide, we will discuss in the next lecture. In this lecture, we will discuss only about, by using sodium hydroxide, how we can find out these metallic cations. So let's start with copper cation. For this, first of all, we have to prepare aqueous solution of the unknown salt sample. Here I have given example just to make you understand. Otherwise, you are not aware that which salt is there, and with the help of that you have to find out. And then add sodium hydroxide solution into it. If you will obtain a blue color precipitate, then it confirms the presence of copper cation in the salt sample. The CuH twice, this is your copper hydroxide precipitate, insoluble substance which is left after the reaction. And this precipitate is insoluble in excess of sodium hydroxide. Moving to the next, I have written two cations. One is ferrous, another one is ferric. Both are of iron metal. Where valency is 2, there we write ferrous. Where valency is 3, there we write ferric. So to find out ferrous cation, again we have to make the aqueous solution. When we add sodium hydroxide into it, it will give a dirty green precipitate. So if dirty green precipitate will be there, it means it is due to the formation of ferrous hydroxide, FeOH twice plus Na2SO4. This is also insoluble in excess of NaOH. Next is ferric. For ferric, again I have taken one example. I have taken this ferric chloride, but instead of this, if some unknown sample will be given to you, if you don't know about the name of the salt, what you will do? You will prepare the aqueous solution, the solution which is made in water, that we call aqueous solution, and then add sodium hydroxide to it. If a reddish brown precipitate will appear, then it confirms the presence of ferric ion in that salt sample, and that is FeOH thrice. This is also insoluble in excess of NaOH. Moving on to, here I have also written the definition of precipitate: insoluble substance which is left after the reaction, that we call precipitate. Now moving on to the next, that is of lead, Pb2 positive lead cation. Salt sample is to be taken. For example, it can be any salt of lead with valency 2. Here I have taken lead sulfate. Aqueous solution, add sodium hydroxide. If curdy white precipitate will be there, curdy white is the observation. If curdy white precipitate will be there, then it confirms the presence of lead cation in the salt sample. And this PbOH twice is soluble in excess of NaOH due to amphoteric behavior. When we add excess of sodium hydroxide to this, it will get dissolved to form sodium plumbate, which is a soluble salt, Na2PbO2. So this observation is not there in copper cation, ferrous or ferric, but it is there in lead. Now last but not the least, that is of zinc cation Zn2 positive. Sample is to be taken, zinc sulfate, just make the aqueous solution, add sodium hydroxide. If gelatinous white, this is the observation, if gelatinous white color precipitate will appear, it will confirm the presence of zinc cation in the salt sample. Again, this ZnOH twice is soluble in excess of NaOH, and it will form sodium zincate and water because it is of amphoteric behavior. So this is how we can find out this metallic cation in the unknown salt sample. Again I am revising the color of the precipitate. For copper cation, precipitate color is blue, insoluble in excess of NaOH. Ferrous cation, color precipitate is dirty green, insoluble in excess of NaOH. Ferric cation, color of the precipitate is reddish brown, insoluble in excess of NaOH. Lead cation, curdy white precipitate, soluble in excess of NaOH. And zinc cation, gelatinous white precipitate, soluble in excess of NaOH. I believe all these concepts are clear to you. Thank you.